Okay, welcome to the 8th grade version of the Semester 2 Algebra 1 review. We're going through all the tests, because if it ain't on the test, it ain't on the final. Let's go ahead and take a look at this. Roll call. We have all of our favorite students here, every single one of them. Not a single one is missing. Incredible. Let's go ahead and get started. We're looking at the test for 6. Let's get this on the screen so everybody can see it. There it is. Okay, cool. For this one, do we want to just go down the page? We only have so much time. Do we want to skip any? Are there any we want to see specifically? What's the game plan? Don't do the first one. How are we feeling about 614?
The first page.
All right. I need confirmation. Should we skip the first page?
Yeah. Do the Euro one, though. Yes, the Euro one.
Okay, if we want to go back to some, we definitely can. Visiting Slovakia. Ooh, yeah, Slovakia. But I forgot to exchange dollars for euros. My meal costs 10 euros. I give the cashier $15. 1 euro's worth $1.32. Then how much change in euros should I receive? There's a couple ways to do this. The way I'm going to do it is I'm going to take the $15 that I gave him and convert that into euros, I think is what I want to do. Here's $15. To convert that, I need to divide by dollars, and I need to times by euros. We know 1 euro is worth $1.32. We need to set it up like this because if you times these, the dollars divide out, and you're left with what? My studio audience is not participating. If the dollars divide out, you're left with what? Euros. Very good. 15 times 1 is 15, and then we're dividing it by $1.32. But this is all in euros. This is great. This is awesome. Do not try to simplify this. Oh, no, please no. Stop. This is how much we gave them in euros. It's true. That's the amount, right? It's going to be less than 15 because you divide 15 by $1.32, you're going to get less. But we don't care about that. All we care about is that the meal costs 10 euros. And so we need to subtract 10 euros from this. Now, studio audience, how do we subtract 10 euros from this to figure out our change? What do we need? Common denominators. We're going to need a common denominator of 1.32. Now, here's the joy of finding common denominators. You're just going to times by 1.32 over 1.32, because that won't change anything, but it will give you a denominator of 1.32. And guess what the top's going to be? What's 10 times 1.32? 13.2. She's unstoppable. So this is what we're going to subtract now. We got common denominators. So it's all going to be over 1.32. What's 15 minus 13? That's dose. Very good. And then we're going to subtract 0.2, which is going to give us 1.8. That's your exact change. It's super gross, but hey, I'm not the exchange rate guy. How does that feel? A little bit better than simplifying, right? Yeah. Cool. I did, but you were in that stage where you're like, I don't want to do it that way. I remember that. That was fun. All right. Do we need to go over percentages? Let's do it. What number? That's X. That's equals 52% is 52 over 100. Of means what? Thank you. Of 300. So there's lots of ways you can do this, but you should go the easiest way. Right now it looks like I'm supposed to divide by 100 and times by 52. What would be easiest to do first? Divide by 100. This becomes 3. And now we have to do 3 times 52, which is 156. Congratulations, you win. Other times it's going to be better to simplify first, but simplification is for you. In this case, we want to keep divide by 100 because 300 divided by 100 is easy. What percent? That means X is the percent. X over 100 of means timesing is 66. Well, we're supposed to divide by 100, right? What if we just divide by 10 instead of 100? We leave one of the 10s left over. You smell what I'm stepping in? We can have X over 10 left over because we divided by one of the 10s, and now we're left with 15. It's kind of clever, huh? Right? It's kind of clever. And then we can divide by 5. That'll get us X over 2 times 3 equals 66. And at this point, why do this? Let's divide by 3 and times by 2, yeah? If we divide by 3, we get 22. And if we times by 2, we get 44. The story here is you need to know how multiplication and division works and what things you can do to make your life easy. If you just started out like trying to divide by 150 and times by 100, I mean, wouldn't recommend. Wouldn't recommend. Try to simplify. That's the idea. How are we feeling about that? Better? 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 Okay, cool, cool, cool. We got 255 is 85%. Percent meaning per century, per 100. Of what number? So X is here. Setup is key, but it's just, reading skills, right? You got to know that of means times, is means equals, etc. Percent means of 100 or over 100. I don't know. I mean, we could times by 100, but maybe we should simplify. 255 equals, both have a factor of 5. The bottom becomes 20. And this one, well, 5 times 10 is 50, and there's 35 left over, so that means 5 times 17 is 85. So now we times by 20 and divide by 17 and circle it? I don't know. What if we times by 2 first, right? Do you see how timesing by 20 would get rid of this? I'm going to times by 2, which leaves us with a 10. And that's going to leave us over here with 510. Then I'm supposed to times by 10. That's going to give me 5100. And then we're supposed to divide by 17, and that's this. You want to know something really disgusting? 51 is divisible by 17. That's really gross, isn't it? It's 3, right? 3 times 10 is 30, and 3 times 7 is 21. That's 51. So this just divides to 300. If you circled this, I would allow it, though, right? If you're like, I don't know, circle it, that's fine. Or you could just raise your hand. I don't know. Guys, the moral of the story, if you're not seeing it, is you need to know how you can simplify to make the calculation easier on yourself. That's what being a mathematician is. Like, could we have just times by 100 and divided by 85? Sure, but the numbers are super gross, right? Finding nice ways to get this done, chef's kiss, that's what it's all about. All right, are you ready for page 3? Let's do it. Oh my God, it's the mediums. Are we supposed to be doing these? Do you want to do these? Yes? Oh, yeah, good. Alice? Yeah, do it. Alice is changing size. Should we talk about that one? I'm getting a nod from Dom, yes. Okay, let's call H her height. So height 1 says the ratio of her original height to her second height, that's this, is 8 to 3. The ratio of her second height to her third height is 6 to 1. And then the ratio of her original to her fourth height is 7 to 2. We want to know the tallest of these 4 heights. Oh, no, we know the tallest is 4 feet. What's her shortest? That's what we want to know. So we've got some apples and oranges going on here, right? I can't really compare H1 to H3 because they're not linked in any way. But if I were to double both of these, 8 to 3 means that for every 8 there should be 3, right? So if I double both of these, for every 16 there should be 6, right? That's not changing anything. That just makes it look different. So now I can clearly see 16 H1s relates to 6 H2s, which then relates to 1 H3, right? So now I've got those all figured out. Based on this, thanks, bud. Based on this, which one's the tallest, H1, H2, or H3? Definitely H1. Now, based on this, which one's taller, H1 or H4? H1, and the tallest is 4 feet. So here's the reality. We know the tallest is 4 feet. So that means if the tallest is 4 feet, what's H2 going to be? It is 6/4. Nice job, Dominic. 6/4 of a foot, which is 1.5 feet, right? So if H2 is 6/4 of a foot, what is H3? 1/4 of a foot. We want to know the shortest height. I think it's going to be 1/4 of a foot, but let's just double check. If I were to make H1 4 feet, what would H4 have to be? That's a tough question. What did I times by to turn 7 into 4? 4/7, so this would be 8/7 of a foot. What's the smallest, 8/7 or 1/4? So we know the shortest height is 1/4 foot. The piggy bank, did it split it over 2 pages? How many nickels are in the piggy bank? Oh, I think it just, yeah, I think for the test I just cut out the extra ones. Remember, it kind of like helps you set it up. All right, so my piggy bank has only pennies and nickels in it, and 2/5 of the coins are nickels. So that means 2/5 of the total amount of coins are nickels. Let's have n equal the number of nickels. A lot of people like to have n represent how much a nickel is worth, but we know how much a nickel is worth, right? So why would you make it the variable? What we don't know is how many nickels there are. Let's have D be the number of, not dimes, it's pennies. The number of pennies will be P. Sorry, I was thinking Mariana problem. So if I take 2/5 of this, that means 2/5 is the total amount of coins, right? And we know 2/5 of the total amount of coins is nickels. So if you take the total amount, take 2/5 of it, you're going to get nickels, right? It says then if I remove 300 pennies, okay, so here's the total amount, and if I remove 300, that's this. Then 3/7 of the remaining coins are pennies. We want to know how many nickels are in the piggy bank. So here's what I like to do, and this kind of walked you through it the first time we did this stuff, is I like to take this first equation and just rearrange it for one of the variables, right? Let's do a substitution or something, okay? So the way I'm going to do that is I'm going to take this, and I'm going to turn it into this. Let's see if you guys see why or how I did that. You guys see how I did that? Times them by 5 to everything. It's going to be fractions, right? Times by 5, times by 5. And if we distribute the 2 to everything, we're going to get this. And that means 2p is equal to 3n. And I'm actually going to leave it like that. I'm actually going to leave it like that because if you notice, like, you could simplify and get like p equals 3/2n or something, right? But look at this, look at this. Look at this other equation. After we times everything by 7, do you see how we're going to get 3n? See how we're going to get 3n? 3 times n? I can replace 3n with 2p and I can win. That's really clever. Let's go ahead and do that. If I times everything by 7, I'm going to get 3 times the quantity of n plus p minus 300. And that's going to equal 3p. Or no, 7p I should say. 7p. Because we times everything by 7 to get rid of that fraction. And when we distribute the 3, we're going to get this. Right? Distribute that 3. And notice we have 3n. We can substitute 3n for 2p, and we end up with this. 2p plus 3p minus 900 equals 7p. I'm going to find the number of pennies and then use that to find the number of nickels. There is a faster way to do this where you just find nickels without pennies, but I just saw that that worked nicely, so I went for it. I'm going to end up with negative 900. Oh boy, is it negative for this one? Is this the negative answer? Equals 2p. That's crazy. Oh no. I set this one up where it's the negative. On the test too? That's crazy. Did I really do that? If I remove 300 pennies, 3/7, 2/5, yeah. Yeah, it looks like we're going to have a negative amount of pennies for this one. Whoopsies. So pennies is going to be negative 450. That's kind of fun. I can't believe I had a negative answer on the test. Did I goof somewhere?
No.
All right, I'm very tired, so it is possible. Timesing by 7 to everything gets this. Timesing by 3, 900. Timesing by 5, 2. Yeah. Yeah, looks like it's correct. 2p is equal to 3n, so we replace 2p, we get 5p. Subtract this, you get 2p. Yeah. So it looks like p is negative 400. That's fun. If p is negative 400, what will n be? Well, 450, I should say. If p is negative 450, what will n be? Now, where are you coming up with negative 300? So check this out. We know that double p, which is negative 900, equals 3n, which means n is negative 300. Your piggy bank is in trouble. It's in debt. Whoopsies! I'll try to make sure it's not negative when I make the answer p. All right, turning the page. The key here, once again, is mathematical ingenuity, right? Trying to make this problem easier to think about, seeing connections. It's got two variables, so we probably want to do elimination or substitution. We did substitution. My baseball team lost 9 out of 13 of its games this season. We lost 15 more games than we won. How many games did we play this season? So, isn't this going to be the total number of games? L plus W is total number of games, yes? Yes? So 9 out of 13 of the total number of games were losses, yes? Now we know that we lost 15 more than we won. So is this true? No, that would mean we lost the same number, right? We lost more, right? How much more do we need to add to our wins so it matches our losses? We lost 15 more. So this is already 15 bigger than this. Right? Losses is 15 bigger, right? We lost 15 more. What do we need to add to W to get there? We need to add 15 to make them equal. Okay. Well, taking this equation right here and rearranging it for W. So if I take this and go W equals L minus 15, which is what Monica was saying, we can replace W with L minus 15 right here and solve. So W is the same thing as L minus 15. And then I'm going to switch colors. I'm going to times everything by 13. This is 2L, by the way, minus 15 after you combine your L's. Times everything by 13, we get this. Looks like 18 L's minus. How do we do 15 times 9? How do we do 15 times 9? How would you do it? That's right, so we get 90 and 45, 135, yeah? You guys have gotten a lot better at that this year. Moving everything around, we get 5L equals 135. That means L is going to be 20 plus 7, right? You guys seen that? 20 plus 7? 20 gets you 100, 7 gets you 35. 27 losses. How many wins would that be then if we lost 15 more than we won? We lost 15 more than we won. 12, which means our total amount of games, 39 games. There's a quicker way to solve that, to eliminate variables, but this works. This works. L versus W, they're not equal. How do we make them equal? 9/13 of the totals is losses. I have on camera a confession. Monaco cannot see because she's not wearing her glasses. This has been true the entire year. Mr. Mack's School for the Deaf and Blind. In a far off land, 8 fish. Do we want to do the 8 fish one? No. Say again? No? Okay. What about Mike and Joe tipping their server? Mike and Joe's easy if you've done it before. Every day, 40% of the fish in a fish store are sold. There are 7,200 fish left in the store. This is your roughest quiz probably because of the English, isn't it? This hard for you? Yes? No? Really hard? Okay. Would it be helpful if I translate this with Google Translate? Would that be helpful or no? Maybe? Mm-hmm. Is that better? Okay. All right. I can help. Okay. 40% of the fish store. We want to do that one or no? All right. So originally, there's some amount of fish. Let's call that F. And the first thing we're going to do is remove 40%. So how much will be left? So 60% of F is how much is left after one day. And then won't 60% of that be left after the next day? Are you smelling what I'm stepping in? 60% of the original fish. And then 60% again will be left on the second day. And that's going to be equal to 7,200 apparently. What can we do to make this problem easier to work with? What can we do? Yes. Yes. Divide? Yes. Isn't this 6 over 10? And this is 6 over 10? And then we need the times by 10 twice, which is timesing by 100. So when we do that, we're going to get 6 times 6f equals, after timesing by 100, 7200 with another 2 zeros on the end. Then we get to divide by 36. Is that going to work out nicely? Will it work out nicely when we divide by 36? Yeah, because 36 times 2 is 72, right? So we end up with 2 with 1, 2, 3, 4 zeros. So originally there were 2,000 or 20,000 fish in the store. It's good when math makes sense, huh? All right. Are we doing the solution one? What's really important to understand about percentages is it always had to be percent of something, right? So, 25% of something. The mixture is acid, right? So we'll say 25% of the solution. We'll use S instead of L. Here, make that note S. Right? And we're adding in 15% acid. So that means we're adding in 15% of the solution that is acid, right? Don't worry, it's about to go away and get really nice. Don't panic, don't panic. So this is the amount of acid, right? Now we need the amount of water. Isn't 75% of the solution? Ooh, hold on. Twice as much 15%, so that's this. 2 times that. 75% of the solution, which is water, is mixed into twice the solution of 85% water. So check it out. The top is all the acid, right? 1 bit of solution at 25%, 2 bits of solution at 15%. The bottom is all the water. 75% of the solution plus double 85% of the solution. Now, check this out. Do you see how everything has an S in it? And everything has a divides by 100, right? I'm going to factor out S over 100 from everything. And what I'm left with is 25 plus, this is 30, right? And then I'm left with 75 plus 170. These divide out, right? Right? They divide out. So now we're going to get 55 over, it's going to end in a 5. 240? 245? Circle it or simplify, I don't care. That's it. Fun fact, it'll always, the S's and the hundreds always divide out. So you know an easy way to set this up? 25 plus 2 times 15, and 75 plus 2 times 85. It'll always be that. The S over 100 will always divide out, right? So start here. It's double the solution, right? Twice as much. So double these guys.
Yeah, that's all we want to do. We don't want to do anything.
All right. 6 is done. 7. I'm sorry, Christina. More words. I know. They were printing 30 minutes ago, and I wanted to hurry up and get things going, so when it's time for 10, I'll grab it. Okay. Who's calling? This is all about proportions, so something being divided equals something being divided, right? A chocolate chip cookie recipe that produces 20 cookies requires 2 3/4 cups of flour. This is definitely directly proportional, which is why we're using division, right? If you want more cookies, you need more flour. If you want less cookies, you want less flour. See how double up, double down, right? That's definitely division. Math club's making 10 dozen. How much is 10 dozen? So the question is, how much flour do we need? Yep. In order to not change anything, we need to times by 6 over 6, right? So that means we're going to do 6 times 2, which is 12, and 6 times 3/4, well, that's going to be 18 quarters. Looks to me like that's going to be, what, 4.5, right? So 16.5 cups. Yeah, let's do it. Let's do it. I love this one. It's so much fun. So 8 people can mow a lawn in 5 hours. So let's think about it. If I increase the number of people, will they mow the lawn faster or slower? Faster, which means it'll take less time. So more people, less time. More people, less time. Inversely proportional. More people, less time. Yeah. Faster sounds better, but it's less time, right? So it's got to be up, down. So this is inversely proportional, so they're going to time. So we have the number of people, 8, times the number of hours, 5. And that's 40, right? But how many people, let's call that P, will mow the lawn in just 4 hours? Well, it's still got to be 40, right? It takes, you need to think of 40 as people hours, right? We have people times hours. The units become people hours. People hours is a measure of how much work needs to be done. That means one person could do 40 hours of work, 2 people could do 20, right? 4 people could do 10 hours, but it takes 40 people hours to get the job done. In this case, if we want it done in 4 hours, people got to be 10. We need 10 people. 10 people, that's it. I know. The number one thing I hear when people come in is, oh, it's that easy? Yeah. I swear to God I did not. All right, turn the page. Promise you. Did not. I think I even have a video going over this. I'm pretty sure I even made a video going over this, and it's exactly this.
Oh my God. I never watched the video.
All right, swordfish, driving a car. I had to think of something. This is not an American thing. I'm just silly. Should we talk about it or do it? Yes. Okay. A swordfish drives a car at 50 miles per hour for 4 hours. What is its average speed? Guys, average speed is total distance over total time. So what's our total distance? Well, 50 miles per hour for 4 hours. What's the total distance there? 200 miles. And then he drove 60 miles per hour for 2 hours. What's that? 120 miles. Now, what's the total time? 4 hours plus 2 hours. Let's go ahead and add them up and divide. You cannot divide individually like this. They're multiple terms. So it's over 6, 320 over 6. Both of them are divisible by 2, so I'm going to get 150 plus 10, which is 160. 160 is not divisible by 3, but if you wanted to, you totally could. It's like 50 and what? 50 and 1/3? 1 and 1/3? 50 and 1 and 1/3? Something like that. 3 and 1/3? 50 and 3 and 1/3? Yeah. But I'm fine with that. That is their average speed. So 53 and 1/3 of a mile per hour, but I'm fine with that. Who is your math teacher? No. Me. That's very cute. So what do you say? Alone, Chloe can dig a ditch in 9 hours. If Ember helps her, the two of them can dig the ditch in 8 hours. How long would it take Ember to dig the ditch herself? Well, first off, if it takes Chloe 9 hours and Ember helps and it only takes 8, Ember's not moving that fast, right? Like, you saved 1 hour by adding another person in, right? So let's set this up. Let's have C be the amount of work that Chloe does, and I be the amount of work Ember does. Well, we know that Chloe can dig it in 9 hours. So we know that if it takes her 9 hours to dig one ditch, a ninth of a ditch is digged in 1 hour. So we're going to say a ninth of a ditch every hour. So that's the number of hours that Chloe is digging. That's what I wanted to say. Number of hours Chloe is digging, right? So she digs a ninth of a ditch in 1 hour. Of course, Chloe would need to dig 9 hours to make that work, right? If Ember helps her, well, Chloe's still digging at the same speed, which is this, right? A ninth of a ditch every hour. Ember, on the other hand, is digging some other amount every hour. Yeah, let's make this H. Let's make this H. This will make more sense. Let's make this H. Ember is speed we don't know, right? We'll have this be a ninth. We'll have this be we don't know yet. So a ninth of a ditch every hour is what Chloe's doing. A ninth of a ditch plus whatever Ember's doing per hour is going to get us one ditch as well. Let's go ahead and solve for Ember's speed. Hmm? 1 over 9. Chloe? Do you don't know Chloe? I call her Chloe because it's funny, but yeah, it's Chloe. I know, silly, right? Yeah. All right, I thought it was a math question at first.
Don't we try to figure out like 1/9?
I'm trying to remember. We know that it takes 9 hours for her to do this. How many hours would it take them both to do? We're solving for 8. Yeah. So for Ember, right? We know how many hours they're digging. How many hours does it take for them to dig a ditch? 8. So we know this is 8. You follow me? So we get 8 ninths, and then 8 times I equals 1. That means 8I equals 1 ninth. So literally Ember, she's digging at a rate of 1 over 72. It will take Ember 72 hours to dig a ditch by herself because she is so slow. That's it. Notice in 8 hours, she'll have dug 8 over 72, which is 1/9, right? Which will complete the last bit that Chloe needs to actually finish the ditch. So Chloe in 8 hours digs 8 ninths, right? In 8 hours, how much does Ember dig? Well, we know that Ember's going to dig in those 8 hours the remaining 1/9 of a ditch, right? So how much is she digging in 1 hour? Divide by 8, a 72nd. In 8 hours, she digs a ninth, right? Fractions or division? Sounds like your math teacher taught you that. Turn the page. Yeah. Eli is standing on the top of a 100-foot flagpole at 1 p.m. Should we talk about this one? Yes? Da. Eli is standing on top of a flagpole at 100 feet, 1 p.m. So Eli's on top here. He's standing on the top of the flagpole. He's about to jump on some kid. 100 feet tall. A 3-foot child is down below and casts a shadow of 0.5 feet. If Eli is 9 feet tall, how much longer is the shadow of the flagpole and Eli together than the shadow of the flagpole alone? Well, here's the deal, guys. We can figure out the shadow of Eli and the flagpole by simply figuring out the relationship between the child and its shadow, right? They're both using the same sun. So we know a 3-foot tall object would get a 0.5 tall shadow, right? So that means a 109-foot tall object would get a what foot tall shadow? 3 gets 0.5. What would 109 get? Well, we'll use what Dom's logic was earlier. 3 times what gets you 109? Well, definitely 109 over 3, right? So we need to times 109 over 3 by 0.5. Wasn't that going to get us 109 over 6? That is how tall the shadow is for Eli and the flagpole. You wish to buy the colors? Help yourself. Now, the question is, how much longer is the shadow of the flagpole and Eli together than the shadow of the flagpole alone? Well, what's the shadow of the flagpole alone going to be? Same logic. 3 feet over 0.5 feet equals 100 over how many feet? This is shadow of the flagpole. This is shadow of together. 3 times what gets you 100? 100 thirds. So if we times by 100 thirds over 100 thirds, that doesn't change anything. It keeps the proportion. What's 100 thirds times 0.5? 100 thirds times a half. Hundred over 6. So this is them together, 100 over 9 and 9 over 6, and this is how it is without Eli, which makes sense, right? It's 9 feet. It's 9 feet difference. That's it. So let's subtract these. Line number 6, also known as 1.5 feet. There is a quicker way of doing this. This is true. But that's the way I came up with as I was just thinking it freestyle in my head. Have to? Okay. Oh! Skittles! Skittles! You like that one? That's a classic. You never seen that Vine? No, you're too busy playing Mermaids in the Basement. Don was sitting over on the phone just having a great time. Suppose X and Y are inversely proportional. What does it mean to be inversely proportional? So it's definitely a times relationship, right? Think about it. If two things multiply to 50 and I raise one of them, the other's got to go down so they still stay multiplying to 50, right? That's inversely proportional. We know Y and Z are directly proportional. That means this. It's saying when X is 5, we have Y is 6, okay, cool, and Z is 3. Whoops, that's division. What is the value of X when Z is 6? Well, when Z is 6, what will the value of Y be? 12. And if Y is 12, what will the value of X be? 5 halves. They got to multiply to 60, right? So the answer is 5/2. Again, these are the medium level questions. Definitely not necessary to pass this class by any stretch of the imagination. But they can't hurt. Turning the page. Oh, no. Nope. That's Ukrainian for stop right now, or I will play. Do you need it right now? I can go get it right now if you want. We're going 6, 7, 8, 9, 10. Whatever anybody needs, yes. We'll do 10 today if we have time. It's just sitting in the copier. I wanted to get started. Yeah.
If I don't finish my final Friday, can I still look for review after school and then take it Monday in the morning?
Maybe. Ah. Hi. If not finish on Friday, take on Monday and go to review. Tomorrow morning, you take final. After school, you review. Monday, you come in early. Maybe. All right, do we need to do the chickens problem? 20 chickens eat 8 bags of scratch, which apparently is chicken feed, in 5 days. I want you to think. If I have more chickens, what's going to happen to the number of bags of food? Up. I'll need more bags, right? So it's double, right, up, which means it is directly, inversely proportional. Directly proportional is what I meant. So chickens and bags are this, yes? What about the number of bags? As I increase the number of bags of food, what's going to happen to the number of days? It also goes up, so they're inversely proportional. Now, this is only true if chicken and days are inversely proportional, right? So think about it. If I have more chickens, what's going to happen to the number of days they're alive? Goes down if bag stays the same, right? So this is definitely true, right? This is an inversely proportional relationship. These are both directly. So the question is, if I have 20 chickens and 8 bags in 5 days, What will happen if I change that to 9 chickens and 30 bags? How many days will it take them to eat that? Okay. Well, we are live, or at least we will be. This right here. I can simplify stuff, right? Isn't this 100 over 8? This right here is 9d over 30. Let's simplify this some more. I can take out a 4 from both of these. This is going to be 25 over 2. This right here, if I take out a 3 from both, I get 3d over 10. What do I need times 2 by to get 10? 5, they said, unsuredly. In order not to change the relationship, we got to times by 5. That means 3d is going to equal 125, right? So d is going to be 125 over 3. Which is like 41, almost 42 days. Days. Well, one's working to do stuff and one's working to get rid of it. So one's going to be positive, one's going to be negative. We're going to see who wins, right? Let's go ahead and talk about it. Bart. I included this one because you love Bart. I will. To the right.
My light,
You're left now.
my light. My light or my red?
Yeah, after I upload it, yeah. It'll take it a little while for it to process,
My
though.
light or my red?
That way, go. Should have told it the wrong way. Should have been gone longer. Bart is writing on a chalkboard that is initially empty. It ordinarily takes Bart 20 minutes to cover the whole board. So how much of a board does he write in a minute? In 1 minute, how much of the board does he cover? 1/20th, right? So 1/20th times t is how much of the board he covers, right? If t is 1 minute, he covers 1/20th. T is 2, he gets 2/20ths. If t is 20, he's got 20/20ths, the whole board, right? However, Nelson is erasing the board. So he's subtracting his work, right? He does it 30 minutes by himself. So how much of the board does he remove in 1 minute? He removes a 30th. Now, Bart will eventually win because he's faster, right? He's covering a 20th, he's only removing a 30th. The question is, how long until the entire board is covered? So when will this equal 1 is what we want to know, right? 1 entire board. Well, how can we make this problem easier to solve? What can we do to make this easier to solve to figure out the time? Huh? You can get commie denominators if you want, but this is an equation. Why get commie denominators when you can just multiply to get rid of fractions? Right? Why don't we times everything by 60? Do you know why I chose 60? No, but that's good that you said that out loud because that is a common misconception. No, I chose 60 because, look, we're going to divide by 20 and divide by 30. What number is divisible by 20 and 30? 60. So we're going to get 60 divided by 20, which is 3 times 1. We're going to get 60 divided by 30, which is 2. So check this out. T is 60. So it's going to take Bart exactly 60 minutes to beat Nelson. Well, there's two advantages. One, if you know how to do them, it brings your grade up from a 90 to a 100 for that. And two, if you get it wrong on the final or a test or something, which would have been relevant to know a while ago, but it's also relevant on the test or on the final, it can only bring you down one category. So if you had all of those at 10s and you goofed on the final, the worst that could happen is it turn into a 9. If you only do the 9s, the worst that can happen is it can turn into a 7. If you only do the 7s, the worst that can happen is turn into a 40. Yeah, what's up? Oh, back? For you. I can do that. The gravity one? Yeah, I can do it.
I think I got it right last time. No, I
It's all of the advanced ones are surprisingly easy. You just have to understand what's actually going on. If your whole thing is like, I'm just going to copy the numbers down, there's no chance. But they're actually often easier than the intermediates. Good? All right, we're going to do this first one by request. The force of the gravitational attraction between two bodies is directly proportional to the mass. Okay, cool. And inversely proportional to the square of the distance between them. So, if the distance between the two bodies is tripled and the mass is halved, what happens to the force of gravitational attraction between them? Okay, so we know that the gravitational attraction, which we'll call G between two bodies, right? We don't need G1 and G2. They both have the same gravity on each other, right? Is directly proportional, well, that means this, to the mass of each body. Well, don't they have different masses? All right, mass 1, mass 2. And inversely proportional to the square of the distance between them. Well, the distance between them is the same, right? Whether you're going from one planet to the other. If we take this and we take the original distance and we triple it, well, that means we got this. And the mass is halved, meaning we're timesing each of these by a half. Right? The mass of each, yeah. What happens to the force of gravitational attraction between them? Okay. Well, we know that these are going to end up being equal at the end of the day, right? As they move away, it's going to be proportional. So let's go ahead and solve. Notice if I divide it by G to both sides, that goes away. This is 9D squared. This is going to be a quarter M1 times M2. So a quarter times M1 times M2. What's going to happen when I multiply by M1 and M2 to both sides? This goes away when I times by M1, M2. And this goes away, doesn't it? What happens when I divide by D squared to both sides? That becomes 1, that becomes 1, right? So this all became 1s. And what do we get? We get 9 over a quarter over here. 9 over a quarter. How many times does a quarter go to 9? 36 times. So this is going to be 36 times the gravitational force. I guess we shouldn't say these are equal necessarily, but it's fine for solving this problem. Technically, they're not equal. They're just, yeah. So 36 times the gravitational force, which makes sense. Think about it. The distance is tripled, so they're further away. Hold on. Does this make sense? They're further away, and the mass of each is halved. What happens to gravitational force? It's 1/36 of what it was before. Pardon me.
Where's 9 come from? From 3D squared to 9D squared.
3D squared is 9D squared when you square it.
Okay, sorry.
No, it's all right. It's all right. These technically aren't equal, but yeah, the bodies are moving further away, and they're getting their mass is halved, so their gravitational attraction is going to be less. It's 1 over 36. Where did I goof here? That's going to get us 1 over 36. I suppose we could have flipped these two things. Maybe that's what we want. The mass divided by the gravity over the distance. I feel like G shouldn't be here at all, actually. This represents the gravitational attraction here. So these go away anyway, either way. Mass over distance is gravity. I suppose so. All right, cool. We're going to skip the Dom one.
That's me. 44, that's me.
Do or no do? When Dom is not on the moving sidewalk, he can walk the length of the sidewalk in 3 minutes. How much of a sidewalk does he walk in 1 minute? A third. Dom does a third of the sidewalk every minute, right? So if T is 1, he's done 1/3. T is 2, he's done 2/3. T is 3, he's walked the entire sidewalk. If he stands on the sidewalk as it moves, so he's standing, he can travel the length in 2 minutes. If he is moving together, like if he walks on it as it moves, this is kind of like Bart and Nelson, except they're working together, right? He's walking right along the sidewalk without it being turned on, he gets this. But the moving sidewalk, if he just sits, right, doesn't do anything and just moves him, it does this. So together, as he's walking and the sidewalk's moving, this is what he does. When will this equal 1, right? Notice that here, it would take 3 minutes for him to walk it alone. Here, it would take 2 minutes for him to just stand on it, right, and move on his own. Together, it's going to be a lot shorter, right? We should probably times by 6. That's going to get us 2t plus 3t equals 6. So what will t be? 1. It'll take him 1 minute if he's walking on the moving sidewalk. It'll take him 5/6 of a minute. 6/5 of a minute. Thank you. Sorry. I gave up right at the end. Turned the brain off. All right, moving on. We're going to number 8. Looks like it because that was the last of the advanced. I'm going to be real. I wrote that final, and there's going to be a bunch of problems I have to take off because I didn't consult the tests. I just did it like freestyle today. So, hooray.
This one's not a light work, not gonna lie.
I mean,
Yeah, plot each point.
okay, we're chilling. I would hope so.
The distance on the slope.
If you make a mistake, it's because you goofed on accident, right? Find the distance between 2 points.
I did that, I did it wrong every time.
Guys, distance is Pythagorean theorem. A squared plus B squared equals C squared if you don't root it, right? Let's find the height of our triangle. Well, that's going to be the delta y, right? What is the delta y? 8 going to -2. It doesn't matter because we're going to square it, but like to get you in the habit of finding slope, I'm going to be consistent, okay? What about delta x? We're on the second page of number 8, Joey. +2. So this is what we're doing. We're going 10 down and 2 over. What's the hypotenuse of that, right? That's going to be the distance. So 10 squared is 100. 2 squared is 4. We get the root of 104, which is slightly more than 10. How you do? Distance between 2 points. Point 1, point 2. Okay? This 3/8. This is 5, -2. Okay? You could do 5 minus 3. Because distance is not 8. See? Here, what? Here, I'll do it up here.
You can just keep it as a root even if it is.
Yeah, that's totally fine. 3, 8, and 5, -2. 1, 2, 3, 4, 5, -2. 3, 8. 1, 2, 3, 4, 5, 6, 7, 8. We want to know this. Observe. Height is 10. This is 2. Distance is 10. Five -2 is a coordinate. Oh wait, hold on, -2. Yeah, -2. 5 -2 this dot. And then 3, 8 is here. To find the distance, we need Pythagorean theorem, yes? This is 10, yeah? This is 2, yes? So we find distance between y values. Distance is 10. Distance from 3 to 5 is 2, yes? Distance. Yeah. You could do subtraction or use brain. Yes, just use brain. 10. 2. All right, slope is the exact same thing except it's delta y over delta x. That's what we're looking for. So you need a fraction for this. The number of people that give me a fraction for this and give me a single number for this is greater than 0%. So let's find delta y. Delta y is the difference between the y values. If we start at -1 and go to 0, what's our delta y? +1. That's the amount of change we're doing, right? So if you had started at 0 and gotten to -1, you would have had -1, right? So it depends on where you start. I'm starting here and going there. Whatever you're doing, be consistent. I'm going to start here and go there. If you do the reverse, your signs will be flipped, but the answer will still be the same. Going from 9 to -7 is a change in the x of what? -16. So our slope, whether you did -1 on top or whatever, is going to be -16, 1/16 overall. That's our slope. So, Dom, if you had gone from 0 to -1, you would have had -1 on top. Then you would have done -7 to 9, which would have been +16, right? So either way is fine. Hello. y2 minus y1 over x2 minus x1. You can, but then you might make a mistake. Here, y2 minus y1 is 1. Minus a -1 is 1. 0 minus -1 is 1. -7 minus 9, -16. Use brain instead. 16, 1. Minus 16, plus 1. Way faster. Do you want to use slope formula? Then use slope formula. I don't care. But don't make mistake when you miss a double negative. 2 negatives. Don't make mistakes. That's why I don't use it. Yeah, be very, very careful. That's why I don't use it. Too much work. Way easier to just use brain. All right, should we graphing this line? Guys, we have defined points that work. Yes, do it? Okay. How about -6, 0, and 0, 9? They work. 1, 2, 3, 4, 5, 6, 0, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Any other points you could have come up with would have been on this line somewhere. That's the point of the line. We know this comes out because -18. We know this comes out because that gets you -18. All right. 832, yes or no? 8th graders get priority here because this is your day. Okay. -4, 3. 1, 2, 3, 4, 1, 2, 3. For those of you watching at home, we're probably going to go a lot slower all the other days. These 8th graders are in a rush because they have literally 1 day to review. All right, so we know that's on our line. So let's plot that. If our slope is -1 over 9, that means if you do -1 for the y value, right, and you do +9 to the x value, you're going to get +5 and 2. Delta y over delta x. This is delta y. You apply it to the y values. This is delta x. You apply it to the x values.
Does it matter, like, if we go from 5 to 2 to 4 to 3? Like,
No, that's fine. Honestly, what I like to do is, instead of writing it down over here, I'm just going to do it to this point. Down 1, right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Are you kidding me? Go ahead and get some sleep. Yeah, it'll be cool. You probably just do it the way I... See? Down 1, right 9. Slope. K is -1 over 9. Down 1, right 9. Down 1, right 9. Okay, then do that. How is formula? Technically, the equation of the line has this in there, right? That's why every point, yes? I don't know. I don't know why. But here, Slope, yes? Negative 1 over 9? How what? Slope is how they change. So if I change 1 in this direction, I get 9 in this. It's a proportion. Got it. What's up?
How did you get 5? Oh, it's rise and run, so it's flipped.
Yeah, delta y over delta x. Everybody goofs that. Yeah. All right, midpoint. Let's do it. Midpoint is what? What is midpoint? The average location, right? You could totally find the distance and then subtract and then like find half of it and then add it back onto the beginning, but like way simpler is to do the simplified formula, which is just add them up and divide by 2, right? So midpoint is a coordinate first off. If you give me one number, oh my god, what are you doing? All right, what is the average of our x values? Negative 6 and 9. What's the average of our x values? Add them up, divide by 2. 3 over 2. 1.5 is the middle of 9 and negative 6. What about the average of our y's? It's 5. Isn't 5 right in the middle of 3 and 7? That's 10 divided by 2. It's the average. You add them up and divide by the number of pieces. Add them up and divide by 2. Add them up and divide by 2. It's that simple. Robeson hasn't seen it yet, and that's okay, because until you do, it's like, what? These are locations, right? The average location will be in the middle. How do you find the average? You add them up and divide by the number of pieces. Add up your x's, divide by the number of pieces. Say it again? Oh, got it. Okay, cool. That's it. Just add them up, divide by 2. Yeah, 3 halves, comma 5. 3 halves in the x direction, 5 in the y direction. Find the equation in standard form. Guys, standard form is this. Basically, yeah. We know that slope is equal to negative a over b, right? Meaning one of the signs get changed, right? That's what the negative means. So let's find the slope. So finding the slope means we got to find delta y over delta x. This looks like plus 11 for delta y, yes? And then our delta x is not plus 7, Dom. What is it? Yep, 3 going to negative 4 is minus 7. Slope cares about direction, dude. So we always want a to be positive, and we don't want any fractions for standard form. So a is always 11, right? That's going to be equal to your delta y over delta x, right? So a is 11, and b is going to be positive 7, actually, right? Because one of these has to get negated. We're going to negate the one that doesn't make a negative. What's up? Dominic, we take this. We do. If you negate a negative, what happens?
Oh, wait, I was looking at
This is our slope.
That's my bad, Topsy. That's my bad.
So are they always positive?
You always want to make this positive. So if the 11 was negative, you definitely want to make it positive, right? But you have to change one of the signs. So in this case, which one are we going to change? Definitely the 7, so we don't end up with a negative 11, right? Then you got to change one of them. I'd change this guy, right? If they're both negative, I'd change this guy, right? Yeah. But now we got to figure out what's it going to equal. Well, if you plug in either of these points, you should get the same number. That's the number that's got to go there. Otherwise, these points don't work in the equation, which means they're not on the line. So if x is negative 4 and y is 2, we get negative 44 plus 14. Looks like negative 30. Fun fact, an easy way to tell if you goofed is plug in this other point. If you don't get negative 30, then you goofed, right? This must be wrong. So let's plug this in. 3 gets you 33. This gets you negative 63. Totally worked, right? Both points, oh, whoops, both points are on the line. Both came out the same, yes? A, standard form. A must be greater than 0. A, B, C exists in integers. That is the rule. No fractions. Z? Integers. -3, -2, -1, 0, 1, 2, 3. No fractions. It's part of the set. Does that make sense? Set of numbers. A, B, and C are part of the set of integers, so they can't be fractions. No fractions. A, B, C, no fractions. No fractions. If fractions, hold on. If this, not standard form. Now standard form. If this, not standard form. Now standard form. Good, awesome.
So it's always the y, like, the one on top, the 11 is always with the x. X.
Yeah, that's your delta y, because it's the a value.
But delta y is always with x.
X is always with a y, yeah. There's a reason for that, and we're going to prove it on a later problem.
Letter B, Rose. Keep going.
This is your Maui dance? I feel like it is.
Do we ever miss you skip over the rest of the easy ones and go to...
Do you guys want to do 851 and 854? I need to know.
Yes.
All right, guys, what form is this?
That's fine. Y is
Slope form.
Yep, so it wants to know what our slope is. What is our slope?
3 over 1.
-3. That's the m value. M is for slope, Monterre, or K if you're from Ukraine. The x-intercept. What do all x-intercepts have in common?
Y 0.
Y is 0. That way they can be on the x-axis, right? What do all y-intercepts have in common? X is 0. Let's find the y-intercept first. It's super easy. If x has to be 0, what are we going to get for y? If x is 0, we just get -1. 0 minus 1. You get the y-intercept for free in the slope-intercept form, right? But what if y has to be 0? That's going to be the other guy, right? 0 equals -3x minus 1. What does x have to be to make this whole thing equal 0? Well, it's got to be 1, right? 1 minus 1. How do I make this a positive 1? What does x have to be?
-1/3, right?
All day. Negatives divide out. 3 divides out. You get 1 minus 1. So -1/3's right there, and 0 -1's right there, and you draw your line. I don't know who hurt you in your past, but like I don't care if it's like, oh, that doesn't look like a third. That looks more like a half. Like it's a sketch, dude. Who hurt you? Find the slope-intercept form. What is slope-intercept form? Very good. It's the one with the slope and the y-intercept. Very good. It says we have a slope of 4. Okay. So we have a slope of 4. And apparently the x-intercept is -3. That doesn't mean we put -3 here. This doesn't give us the x-intercept, gives us the y. We know that -3, 0 works, right? So we're going to use the Ukrainian method. We're going to plug in -3 and 0 and find b. This isn't the Ukrainian method. This is the way we're taught in America as well. But you use it for everything. Exhausting. Exhausting. So what does b got to be? It's got to be 12. So you need to write the equation. That means this is true. Minus 12. Minus 12. Wait, no, plus 12. We were right. Plus 12. You did it. Notice -3, 0 works. So it's on the line and it has the right slope. So there you go. All right, moving on to the intermediate questions. No more doing the worm. What? Yeah, plus 12, plus 12. I made a mistake, yes, plus. We need to do 814.
I got that right on the check sheet. You need to update that to a 90. For the first guy.
Did you send me the thing? Remember I sent you an email being like, where's all this stuff? And you're like, I don't know, man, I'm confused. And I'm like, cool, and you never got back to me.
But then I checked it back and I did do it, but I just didn't email it back.
You just email me back and I will fix it. What is wrong with you people? I'm like, Dom, thank you for sending me this, but it's not in there. And then you're like, okay, I'm just really confused. And then that was it.
Can I do it right now?
Yes. Send me an email right now. It's like,
Is that funny, Christina?
it is. It's like, how do I help you?
This is being recorded live, by the
You
way.
just send it. I'm like, Dom, I love you, but there's nothing here. You're like, oh, I'm so confused. I don't know. I'll get back to you. And then you never did. And you're like, why didn't you plug it in, Mr. Mac? Why didn't you plug it in? What do you want from me? I sent an email to Christina. She understands. I sent it to Dom. He's confused. All right, Christina. How far away is 10 negative 9 from 0, 0? Is it the furthest away? We'll find out. We need to do Pythagorean theorem. This is 9. Yes? This is 10. Yes? Pythagorean theorem. 181 rooted. That is the distance, yes? What's the distance for this one?
The same thing.
Okay,
Same distance, yeah?
yeah.
Yo, yo, yo,
Yo,
yo.
yo.
Now it is 10 nines, the same triangle, yes? 10 9, same triangle. Root 181, so that is a tie. What is distance here? Very easy. 121 plus 49. Looks like 170. It is not the biggest. Root 170. This one, 144 and 25. 169, not the biggest. This one, 169 and 9. 178. Which is the biggest? These two. Tie. Whoops. Yes. Oh, you have to go?
No.
Oh.
Wait. This is how fun it should be like every day. This is so fun. Yeah. I'm actually doing something really important. I'm texting my mom. Really important. Yeah, it's important. You know,
Okay, you didn't do this one.
If we could do class after Dom has already had like all his vapes and everything, then it would be just like this. Okay? All you guys, you see, right? But in the morning, you guys are like, "Ugh."
I wake up a minute before I have to leave.
I know.
Like 7:40.
If I could control everything, I would be like, math is illegal before noon. It's that simple. It's that. But it's. But I.
I need to look up like at 5 and 10 will be at 5 will be
Wait, no, come back.
I am the same guy. But this also helps. This is the second time you've seen it, right? Right. This is review. Review easier. Yes.
That's so crazy.
How do we graph this?
Oh, that's easy. That's like the
Wait, I
undefined one.
just need to know like the slope thing. So if it's like
Y equals negative 5. Give me a point. Nope. Stop. I am doing it for the future, not just for you. It's not just about you. Give me a point where Y is negative 5.
Oh, no, 0, -5.
Good. Give me another one.
1, -5.
Every point you give me is going to be like this.
Oh,
Right? 1 -5 is here. 2 -5. 3 -5. What's it going to look like? A horizontal line. What is the slope of a horizontal line? How steep is it? 0. Think about it. Delta y over delta x. Adeline, pick 2 points. What's our delta y here? Have we moved up at all? No. And we've moved right 4, haven't we?
yeah.
Up 0, right 4. 0 over 4 is just 0. Yeah? Give me a bunch of points that have x as negative 8.1.
8.10.
Negative 8.10.
-8.11. -8.12. And then that one would be undefined.
Hold on. Yeah. Do you see how all of these are going to have different y values, but they're all going to have the same x value? So this one is definitely a delta y of something and a delta x of 0. Delta y of something, delta x of 0, we're dividing by 0. Undefined.
wait, I don't get it. How is one zero and then the other one?
Delta y over delta x is rise over run. Yes, that's the slope.
Yeah.
Pick 2 points on here. What's the delta y? Looks like plus 4. Pick 2 points on here. What's the delta x? 0. 4 divided by 0? Undefined. You can't divide by 0. Absolutely. Absolutely.
No, I'm asking an actual question. No, ask the question.
Yes, what's the question? Minus 5. I'm sorry. Minus 5. Y is always minus 5. X is always negative 8.1. 2 points. You understand? Y always negative 5? Okay. Whoa, 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 whoa. There. Whoa, 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 whoa.
Can you get Kyle, please? Actually, I'm gonna look that up.
It's fun.
And look, and T,
Right out there.
and T, and T, and
Are we doing 824 or no?
yes.
Okay.
Yes.
Never mind.
All right. Estimate the slope of this line.
Wait.
No,
Zero, my
0.
bad.
Because, yeah.
Estimate the slope of this line. Which one? They're both the same, undefined.
Yes, I do that.
This one, estimate, looks exactly like negative 1, right? Negative 4 over 4. That's just exactly equal to negative 1. This one looks like a big positive delta x and a really tiny positive delta y, right? Right and up. So give me a slope that has a small delta y, 1, and has a big delta x. Because it's not exactly negative 1 or 0 undefined, what you have to tell me is how it relates to 1. Is this greater than or less than 1?
No.
1/10 versus 1, which is this less than?
Greater.
1 is greater, slope is less than, yes? Okay. This one is definitely going to the right and up. If it's going to the right and up, those are both positive directions. Delta x is positive, delta y is big and positive. Give me a large delta y. Give me a small delta x. That works, right? 2 and 20, they're both positive. You need to make sure they're both positive, though, right and up, correct?
So M is greater than 1?
M is greater than 1. Notice, big slope, very steep. Shallow slope, not very steep. Watch out for the negatives, though. Estimation. Estimation.
I don't wanna die. I don't wanna die.
Christina, they got Ukrainian rap, hip hop.
Oh my gosh,
Big
I have
Ukraine.
to turn that on this instant.
I'm just
The,
not really listening.
the Ukrainian 67 is 52.
I listen like gothic music in Ukraine. I don't know. It's really good.
Yeah?
Yeah.
52.
Ukrainian man. And we have like 69.
8.3.1. I beg of you.
Oh, really? Do we have to?
I mean, I can't look at the check sheet, but like, you're here. And also, this is your job, even though you're doing it for free.
All 3 points are on the same line.
No more phone.
She has pictures of. Wait, we're live. You can't touch your phone. Can't do that. There's that little Indian boy on there or whatever, right? Yeah, I know. But it looked like one of those commercials that you see. They're like, for 10 cents a day, you can save this little boy's life.
I should send it into one of them.
You should. And then they're playing In the Arms of the Angels. Oh boy. Ah. Guys, if they're all on the same line, what must be true about them? If they're all on the same line, what must be true? They all have the same slope. So we're going to find the slope between these two guys and the slope between these two guys, and they're going to be equal. Okay, cool. So let's find the slope. We have to actually use slope formula now because the numbers are so awful. So check it out. 4, which is the y value here, minus the y value over here. Watch out for the double negative. This is why I do not like slope formula, because you guys always miss the double negative. Then we've got 3, which is the x value from over here, minus the x value from over here, 2a plus 7. Delta y over delta x is y2 minus y1 over x2 minus x1, right? So subtract the y, subtract the x's. Subtraction is distance, okay? We know this is going to be equal to the slope between this point and that point. So we have the same y value, but we have a different x value this time, or a different y value over here, right? We have an x value of 3, and this time we're subtracting the x value over here. y2 minus y1, x2 minus x1. y2 minus y1, x2 minus x1. The slopes are equal. Watch out for the double negatives. That's why I use parentheses for all the numbers. 4, negative 6. 3, 2a plus 7. 4, negative 1. Y values, because rise over run, right? X values. 3, negative a plus 15. All minus, because subtraction is distance, yeah? Okay. Now let's simplify. This is 10. 3 minus 2a, and also minus 7. No, these aren't both a's. 3 minus 2a and also minus 7. Do you see how we're minusing all of this? So let's do 3 minus 7. What's 3 minus 7? And we're all supposed to minus 2a. Okay, cool. Top is 5. We're doing 3 minus 15, negative 12, and we're also minusing a negative a. That's this. Now, we're going to get rid of fractions. How are we going to do it? We're going to times this to both sides. These divide out. That's why we did it. And we're going to times this to both sides. Negative 4 minus 2a. Negative 4 minus 2a. Because that divides out here. And we end up with 10 times negative 12 plus a equals. Doing it to myself. 5 times negative 4a minus 2a. Oh, 4 minus 2a. Negative 4 minus 2a. Distribute and solve. Negative 120 plus 10a equals negative 20 minus 10a. Simplify, simplify, simplify. What's a got to be? 5. The only number that's going to make them all on the same line is if a is 5. It's a lot. It's an. Could be. Sometimes it can be. Well, maybe you should have not cheated then, huh? Oh, so we didn't learn our lesson. Perfect. Even better. Shout out to Marie Monaco. You heard it right here. She cheated. All right. We done? Marie, have a conversation with your daughter. 833, yes or no?
Yes.
It's really easy if you know how to do it. 3-3, yes? Standard form. It's got to go through this and has this slope. Observe. If this is our slope, that means we need 3x plus 5y, yes? Never have a be negative, and we got to change one of them, so which one are we going to change? This one, right? Now, how do we find the number that goes here? Yeah, right? Those points have to be on the line, which means they should work in the equation. So to make sure they work in the equation, we need to make sure this number over here is 9 minus 15, negative 6. Do you see any negatives in front of here? No. Do you see any fractions? No. So this is standard form. Turning the page. 855, prove that the slope is always going to be negative a over b, the thing we've been using this whole time. Yes or no?
Da.
Da.
Yo, time on show. 52.
We're going to make this look like this. Turn this to this. That is our goal. Because if this becomes this, whatever's here next to x must be the slope. So how do I make it look like that? Well, I need to subtract ax from both sides. And I need to divide by b. Ooh, also a big difference between now and like regular class is this is 8th grade only, isn't it?
Wait, so
I have been trying to convince people for years to allow that to happen. They will not do it. Hello.
what are you gonna do with the other people in the
That's a great question. I'm not sure.
Send them to the library.
Ooh.
Maybe
So this proves, right, that this equals m. Yeah? Yeah. Coefficient of x.
yo.
861, yes or no?
Yes.
Yes.
All right. Reminder.
Time on that.
Perpendicular means that the slope is reciprocated and negated. So the slope of this one is negative 3 and 4, right? Or, well, it's really going to be 3 over 4, right? If we change the sign back, that's going to be the slope. So what we're looking for is a perpendicular line. That means we're looking for a line that has 4 here and 3 there. And we negate another one, right? There you go. See how it changed one of the signs and it flipped it? That is perpendicular, yes. Reciprocal?
Yes, I need the calculator.
Mr. Mr. Maybe in his room Monday? Is it up there?
You gotta come over to get it, probably. Yeah, that's fine. I don't care what you do. Yeah. All right. Hey, the line we're looking for has the same x-intercept as the original line. What is the x-intercept of the original line? 8 over 3, comma 0. So 8 over 3, comma 0 got to work in this guy too. If we plug in 8 over 3 and 0, we're going to get 32 thirds plus nothing. That means this, yes?
Yeah.
What is the problem with this answer? Everybody circles this and they get it wrong. Why is this not right?
I have no idea.
8 over 3, 0, that's right. We get 32 thirds, that's right. What's the problem? This isn't standard form. Why?
Because we need.
We can have fractions again.
No fractions. You're not allowed to have fractions. That's what A, B, C exists in integers means. And A has to be greater than 0, not negative. Technically greater than or equal to, but I don't know. It's a gray area. A, B, and C have to be integers. That's the rule. This ain't an integer. Times by 3. Boom, done. Find an equation that goes through this and is parallel to this. Guys, parallel means what about the slope? Same slope. So if we rearrange this guy, notice we want this slope, yes? Slope equals 2 over 6. Parallel slope equals 2 over 6. Da?
Yeah. Dinosaur.
But it has to go through -1, -7. -2 plus 42? 40.
Top K. Chris, you know what that means?
Huh?
You know what top K means? Yes, sir. What?
Yeah, I know.
What is super mean?
You guys really did it. You know what it means, Mr.
I'm posting this on YouTube and it cannot have any bad words in it.
Oh,
ha.
You're far enough into the video. You can get, you know.
We're going to 9. We've got less than an hour. We got to do 9 and 10.
Wait, 9 is not that bad. We don't need.
That's what I've been saying.
It's not that bad because we've been doing it.
Easy. I promise.
Let's do 9.31 on the first page.
Oh, no, we don't know.
Guys, how can x be greater than and less than y? It can't be. So how can this be true? They must be the same. So we've got x minus x, and that means it's 0. Here, we're not allowed to change the order of the numbers, meaning which one's biggest, right? So by squaring it, are we changing how big they are? Yes, but not which one's bigger. So by squaring it, we get 4 root 5 and 7 root 2. These are definitely different numbers. But if the inequality is going this way or this way, it's still going to be true. If we square it again, we're going to get 16 times 5 and 49 times 2. We can easily compare those. This is definitely bigger. Wait, no, 98, that's 80, my bad. This is definitely bigger, which means this is definitely bigger, which means this is definitely bigger. Yay. Question for the peanut gallery. What is bigger, 1/2 or 1/9? Smaller number on bottom better, yes? 98, 80. 98. So we want smaller number on the bottom, right, Adeline? Notice that this right here has everything this has, right? Except it has plus 2. This has everything this has, except we're adding 100 and 102. So which bottom is bigger? Which denominator? This one. See how this one's just 2?
So the right is bigger.
So the right one must be bigger because the bottom is smaller.
Not 10.
This is the exact same number as this. This one just added 2. This one added 100 or 202. This bottom number is 202 bigger than this one because it's only 2 big, right? They're the same number here. So this one's plus 2, this one's plus 202. So definitely bigger on the bottom here. Yeah. Robeson, yeah. Okay. Using interval notation. This is super easy. Subtract 1 from everything. Divide by 3 to everything. When I divide by 3, do I need to switch the signs? When do I switch the signs? When I divide by a negative, did I divide by a negative? No, I did not. So how do I write the interval notation? X exists between -2 and 2. It's square brackets because it can be -2 and 2, right? It can equal those things. If it didn't have the lines underneath here, we'd use curvy brackets. If I just had this, x would go from -infinity up to 2. So I'd have -infinity here up to 2, right? And -infinity would always be curvy because -infinity is not a number. Turning the page.
I don't think we need to put any of those good.
Yeah, I'm too on both of them.
933.
Yes.
Population.
Yes.
No.
Yes.
This is the starting population. We are adding 162 every month. We want to know when does it get bigger than 13,000? Solve for M. We subtract 9,000. Guys, let's do this together. What's 13,000 minus 9,000?
4,000.
Take away 400, we're at 3,600. Take away 40, we're at 3,560. Take away 4, we're at 3,556. All right, now let's estimate. At m equals 20, we get 3,240. Yes? Dog? Male dog is dog. Gmail? Gmail. At symbol. A-T. At. So, Mac at Gmail.
No, this is like dark
Dot.
Just like, we have them, but we don't know for what.
Is it okay if I just guess and check on this problem?
Well, here's what I'm doing. I'm saying if m is 20, we're going to get really close, right? 3,240? So if I do 21, it's going to add 162 onto there. That's going to get 3,100 or 3,402. Add another one on there. I'm going to get 3,564. That's too much, right? So 2 was underneath, 3 was over. So we need 23 months.
Oh, I see. 23 my birthday.
There's August 20.
I don't think that was the point of that question, but okay. All right, fam. Do you know how to graph it if it was an equal sign? Yes? Let's graph it if it was equal. We do care about where it's equal, right? If we didn't care about where it's equal, you would use a dashed line.
I know.
So 6, 0, 1, 2, 3, 4, 5, 6. Negative 3.
And 3. I'm ready.
Any of those would have worked. Guys, because this does care about where it's equal to, we're going to do a solid line. If it didn't, like this, we do a dashed line. Now we need to figure out where is it greater than. This is where it's equal to, right? On the line is where it's equal to. To figure out where it's greater than, what we need to do is check a point like 0, 0 that's not on the line. Does 0, 0 make this true? 0 minus 0 greater than or equal to 6, is that true? 0 is not greater than or equal to 6, so it must be over here where the greater part is. The line represents equal to, the shaded area is where it's greater. Just pick a point that's not on line, test it. That's it. Otherwise, what you've done is graph this, and that's not this, right? Equal to is that bottom thing. If for some reason, Cooper, it was this, you would have drawn a line like that and shaded, because it doesn't include the line, right? Okay? Because equal to isn't there. All right, we want to go over the mediums? Yes, no, maybe so?
Yes.
All right, check this out. I know x is less than y, and I want to prove this. Do you see how x and y are on the bottom? Let's divide by x and y to get them on the bottom. If I divide by x, I end up with this. But here's the thing. What do we know about x and y?
That line.
What does that mean?
Negative.
So I divided by a negative to get here, didn't I? So I gotta flip the sign. Oh! When I divide by y, I get here. Oh, wait, hold on. That's a y, not a 1. My bad, hold on. That's a y. Y divided by x is y over x. If I divide by y, I get here. But what do I got to do? Because y is negative. Again, and every time when I'm tired, I think, oh, I messed up, right? I should have had that for the proof the other way around. But no, this is right, isn't it? 1 over x is greater than 1 over y. All we have to do now is just switch the order. 1 over x is greater than, right? That's what it says. Greater than 1 over y. Done.
How did I get that wrong?
That's the proof. Right? We started with what we knew, and we did legal moves to get here. Dividing by negative changes the sign. Negative.
So that's 12 though. I need 4.
921. You guys ready for this? You cannot square or cube these. It doesn't work. Here's the big brain play. Are you ready?
Yes. Yes.
This is the same thing as taking 5 to the half power and 2 to the 1/3 power, also to the half power. Are you seeing it?
Kind of.
5 to the half power, yes. 2 to the 1/3 power, also to the half power. Yeah?
I don't think so.
Page 3. Page 3. Do we agree? Yes? Yes? Simplify. Yeah? Now, over here, this, if we simplify, is 2 to the 1/3 and 6 to the half, all to the 1/3, yeah? This is 2 to the 1/3, 6 to the 1/6. Now, what can I take these to the power of that I have to do the same thing to both, right? What can I take these both to the power of that's going to get rid of all these exponents? What can I take them to the power of that's going to get rid of all these? Take it to the 6th. That won't change the order because I'm doing it to both of them, right? 5 to the half power to the 6 is really just 5 cubed. 2 to the 1/6 of the 6 is just 2 to the 1st. This is 2 squared. This is 6. We can easily compare these now, right? 125 times 2 versus 4 times 6. Which is bigger?
Boom.
You've been guessing it's a 50-50 shot. I've been really nice. You have to show your work on the final. This is a prime example of a question you might have gotten a check mark for previously because you're just guessing, and then you're going to prove on the final you have no idea what you're doing, and I'm going to take it away from you. Got to show your work. Turn the page. Well, half the time you'd be right, unless you're a really bad guesser. How can we compare these two without changing which one's bigger or smaller? Not divide it by 10, but we can rethink of it as 2 to the 5th to the 10th and 3 to the 3rd to the 10th. So we have 32 to the 10th versus 27 to the 10th. Which is going to come out bigger? Yeah, so clearly it's this guy. All of this is easy. You just have to think. Problem is that Dom has not had his substances. Yeah, you should definitely like pregame. Yeah. Apparently it works well for you. All right. Here we go. We're going to graph this. We're going to graph this. We're going to split it up because we know how to graph these individually, yes? Cool. This will be purple. This will be green. So let's graph the purple. Give me numbers for x and y that make this equal to. Give me another set of numbers. Has to be equal. We're going to find the line first. Remember, the line's where it's equal to. 0 and 2. So here's the line. Notice it does care about where it's equal to, right? So we're going to use a solid line. Okay? Now, we're going to shade in a second. Okay? What we need to do is pick a point like 0, 0 that's not on the line. If I plug in 0, 0, is 2 less than 0? So we got to shade over here, right? We're not done yet. Let's graph the green one. Give me 2 points that make this true. Give me another one. Now let's pick a point that's not on the line. How about 0, 0? Does 0, 0 make this true? It does, so we shade this side. So where do they agree? These are all the possible numbers. Any point in here would work for BOFA. That's what we want. That's it. None of this is. It never has been. Yes.
No, whistle. Whistle? Yes. Like,
Like in a real before, if you will be doing system in place, like in house, you will not have money.
If you whistle in the house, no money?
yes.
It's a superstition.
Good thing I can't whistle. This is how I made the house. That's why I'm not do like whistle. I didn't know like how.
You want to have money. All right, pool. Mitch's pool, yes or no?
Yeah.
Hey, look, it's 10,000 gallons this time. Monaco, what's 80% of 10,000 gallons? 8,000, thank you. So we're starting with 8,000 gallons at noon, right? That's 80%. And then we're losing 120 gallons every hour, but he's filling it up with a hose that fills it up at 225 gallons per hour. We want to know, when will this overflow the pool? Meaning, when will it be over 10,000 gallons? Well, it's not going to take long, right? Because as Monaco is surely aware, we know that this overall is really like we're adding 105 gallons an hour, right?
Question. 1 p.m. between, oh no.
13.
Oh, it's like
1,300 hours, 13 o'clock? 1 o'clock?
Ah, yes.
Yes.
It's 19.
It's 13 and then the class is 14 and then I have another place.
It's something in between 15 to 20. That's it.
2 o'clock.
So check it out, check it out, check it out.
Check it out. Woo.
20 is going to get us 2,100 gallons. That's going to put us barely over, right?
Oh, wait, but that'll be
It's exactly 20, isn't it, right? Because if it was 19, we're going to get 2,100 minus 105, which is going to get us 1,995, right? So it's got to be 20. H is 20. That's when it'll first overflow, right? 2,100. If you take another hour away, we're going to get 2,000 or 1,990. No, 1,895. No, 1,995. Okay, the last one. Yes? So, when will it first overflow? At what hour? He checks every hour. So, 19 hours? No. 19 times 105 plus this? No. 20 hours? Yes. Times 20. 2,100. So greater than. We win. So 20. All right, check this out. Here's what's going to happen, okay? We're going to get a bunch of inequalities. They're going to look like this or something, and we're going to shade, and this is going to be the only area they all agree in. But what we want to know is where is the maximum and minimum? We're going to try and maximize and minimize this. So imagine one of our points was 5, 1, and the other point was like 2, 0. 5, 1 makes this 21. 2, 0 makes this 8. So 5, 1 will be our max. What we need to find out is what point inside of here is going to get our maximum and minimum out of this. Now, here's the secret. We don't need to check all infinite points in here. Our max and our min, if they exist, will always be at the points of intersection. So we don't even care about the shaded region. So what makes things shaded? Inequalities. What's easy to figure out where the lines intersect? Equalities. So let's just have this be this and this. Okay, we don't care about greater than or less than. That's going to be the shaded part, right? We also know that this has to be true. And this has to be true. Let's find where all of these intersect. Those are going to be points, right? And then we'll plug them in and see which is the biggest, which is the smallest. So let's find where they intersect. What I like to do is I like to figure out where this line, y equals -2, which is going to be like right here, right? I like to figure out where that intersects with both of these guys. Let's figure out where that intersects, okay? So when y is -2, I'm going to have -2 equals -3x plus 5. Right? Where they intersect, they're going to have y equals -2. So what will x be? What does x have to be to make this whole thing -2? We wish this was -7, right? -7 plus 5 is -2. How do I make that -7? It's already negative, so just 7/3. 3 divides out, we get -7 plus 5. What about when this one intersects with this, right? -2 equals 3x plus 5. It's annoying that these are so similar. We know when y is -2, what will x have to be? That'll be their point of intersection here. It's -7/3, yep. 3's divide out, we need -7. Cool. What about when y is 2? That's the other line, right? That's like this guy right here. We're going to find their points of intersection. So what happens when y is 2? Well, when y is 2, we get this for this line. Nope. What's got to be here? What's x got to be? What do you add 5 to get 2? How do I make that -3? +1. It's already negative. So this intersects at 1, 2. This line right here and this line right here intersect at 1, 2. Now what about when we have the other one? Where is it going to intersect with that line? When y is 2, what does x need to be? -1 in this case. Now there's one last thing we got to do. We got to figure out when these two intersect with each other. Obviously, these two will never intersect, right? Y equals 2, y equals -2. They're parallel. They're never going to intersect, right? So where are these going to intersect? Well, to do that, aren't they both equal to y? Do a substitution. Replace y here with this. Yeah? Right? They're both equal to y, so they're equal to each other. If I subtract 5 from both sides and add this, I get 6x equals 0. So what does x got to be? So that means 0 when y is what? Let's find out. If I plug in 0, what will y be? If I plug in 0 for x, what will y be? And notice that works for BOFA, right? That's the point of intersection. So now we got to test all these points here to see which one comes out biggest and which one comes out smallest. So let's go ahead and do that. If I 0, 5, I plug it in. I'm going to get 5, right? Do you guys see that? Plug in 0, plug in 5, I get 5. If I plug in negative 1, 2, I get negative 4 plus 2. That's negative 2. If I plug in 1, 2, I get 6. So right now that's our max, right? If I plug in 7 thirds and times it by 4, I get 28 thirds. That's like, what, 9 and change? 9 and a third. And I subtract 2. That's 28 thirds minus 6 thirds. Looks like 22 thirds, right? 28 thirds minus 2 minus 6 thirds. 22 thirds is 7 and a third, right? So that's definitely our max right now. If I plug this in, we're going to get negative 28 thirds minus, oh wait, hold on, this was plus, wasn't it? Pause. No, it was minus, we're minus. This is negative 34 thirds. So, fam, what do? We found out where this intersects with both of the other lines. We found out where this intersects with both of these lines. And we found out when those two lines intersected each other. That's going to give us all of our points, right? Here, 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 and here. And then we have to try them out in here to see which ones come out the biggest and the smallest. When I plugged all these in, the biggest one was definitely this. That's 7 and a third. So our max is here. That's our max. That's going to maximize this thing. Which one came out the smallest? The one below it, right? So negative 7 thirds and negative 2. I'm sorry. That's how it is. That's the last intermediate. This is a really good problem.
We have 40 minutes. Maybe
Wait,
the
give the
hard
person
one.
10 seconds.
Yeah,
We
for
just do
second.
10 basic.
Yeah.
Yes. We're going to do 10, yeah?
Yeah.
All right, we're going to take a short break. I'm going to go grab 10s, okay?
Can you clap for that? Let's do a clap.
I'm not in the hard one problem. I don't understand.
Clap your hands.
We are recording right now. So you got to imagine they can't see, but they can hear, right? Adeline, Monaco, I'm going to throw this bowling pin at you.
Wait, so it's just like
Why did you?
Yeah, you should have yelled. Yeah, there you go. Okay, perfect.
You're getting off.
You just like so shocked that you didn't get it. That's when you chop off your arm.
Because whenever you turn the
Close it.
I have
Please,
4 quarters.
please tell me
You owe me
you
$1,
need
so
this.
yeah, I'll give you $1. I'll just give you $1 at one. Either way. And yeah, see the back?
God.
Quarters now, it's $1.
All right, it's game time. Let's do it.
Okay, sure.
Fam, what do you divide by -5 to get -5? -25 divided by -5 comes out +5.
I'm at 25.
So, you know, x squared has to be 25. What two numbers do you times by themselves to get 25?
And negative.
I'm at. Wait, I have plus
Yeah, it's got to be one or the other, right? All right, there's a couple ways to do this next one. You could rewrite it like this. This one's so easy. The last two are so easy that a lot of people get confused on them. If I do this, what common factor do they both share? If I take it out, can you tell me what numbers are going to make this equal 0 when r equals what and r equals what? And?
0.
0 times 13. Wow, didn't know that was allowed. All right, so fam, another way to look at this. Here's another way to read this. What number times -13 is the same as that number squared? Do you see how -13 times -13? Right? Is -13 times -13? But isn't 0 times -13 also equal to 0 times 0? Yeah. 70 times my number is equal to the square of my number, not square root, divided by 5. What are the possible answers for my number? And there will be 2 of them. What if we rearrange this and solve, huh? Let's times everything by 5 and get 350x equals x squared. And then let's subtract that over. What common factor do they share?
So it'd be 0 and 350.
Now, a common mistake is people think, ooh, I can just divide by x to everything, right? And I'll divide it from here, here, and here. 0 divided by x is 0. This is true. But x could be any number, right? What if x was 0? Can we divide by 0? That's why we never divide out these x's. We always factor it. Because look, x was 0. If you divided by x, you would have gotten this, right? And you would have only gotten one answer. And the reason is because you accidentally divided by 0 to get from here to here. And that's why you only got one answer. Never divide by x if x can be 0. You have to be able to prove it can't be first. Okay? Always factor. All right, this. Rewrite this so that it's easier to see. Why do you guys never do this? We want to know when this equals 0. Well, it's much easier to solve if we factor, because then it's timesing to 0. We need 2 t's. What else do we know we need to have? We could have 1 negative, 1 positive. Because it's got to multiply to a negative. The 2... Yes, always factor x out. Never divide x. No. Bad. Bad, Ukraine. No divide by x. X could be 0. Not allowed. Always factor. Okay. Yeah. All right. Everybody. I know I need a plus and a minus to multiply to this. Whatever number here and here doesn't have a t in it, right? So it's going to multiply to something without a t, which would be -18. What two numbers multiply to -18 and add to -3?
9 and 2. No, it's not 2.
6 and 3, -6 and
There you go.
Which means our answers are t equals -3 and t equals +6.
Okay.
That's the number one thing people say.
How do you figure out like which side the plus and minus on?
In this case, it was symmetrical, so it didn't matter. Does that make sense? And then once I put the 6, it has to be -6. Because when we distribute to check it, let's check our work. T times t is t squared, right? This is going to get us -6 t's. If it was a plus here and a minus there, we'd get +6 t's minus 3 t's, which get a +3. We don't want +3, we want -3. So I know the negative has to be the 6. Making sense? Okay, cool. This one, let's rearrange it. X squared minus 15x plus 36 equals 0. If your equation doesn't equal 0, you can't do this cool thing where the answers are obvious, right? It has to equal 0. Because multiplying to 0 is obvious. Multiplying to anything else, like this, is not. It's got to be double negative. You're right, Dom. Only 2 negatives will multiply to a positive and give us a total of -15x's, right? It's 12 and 3. So x will be 3 and 12. Do not think you're done as soon as you're done factoring. A lot of kids just write this and they're done. I'm like, dude, you never answered the question. right? 3 and 12 are the numbers you plug in to get 0. Da?
It's top of the thing.
Tak? Not da? Oh, da is Russian. Russian. I'm sorry, tak. I apologize.
Is German. Yeah, yeah.
No, it's Spanish.
No, it's not. All right, that's fun. Guys, if this is our equation, the sum of the roots, meaning the sum of our answers added together, will always be what? That was class today.
It was? Wait, Thomas said don't remember.
The answers to the equation will always add to this. So you could find your answers here by factoring and then add them up. But why would you do that? Why would you factor this, find your answers and add them when you know they're always going to add to this? So if we want to find the sum of the roots, we know it's going to be negative b over a. A in this case is 1. It's negative 5. That is the sum of our roots. Our answers are going to add to negative 5. The product, on the other hand, is always what? C over A. So this is negative 176 over 1, which of course is just negative 176. So apparently our answers add to negative 5 and multiply to negative 176. Can you think of any numbers that do that? I can't off the top of my head. Good thing we don't have to.
I have a question.
Yes.
So we don't have to do chapter 10 check here, right?
If you've got stuff, turn it in. If you don't, then don't. Same as always. Can't hurt you, can only help you.
Wait, I'm confused. I thought we don't have to do those
But
extra
for this final watch, if I don't finish it in class, can you invite me as class? But I don't have to go for that.
During homeroom or to be late for gym? I thought it was against the law to be late to gym.
But my mom put it in.
I thought it was be against the law to be late to gym.
I don't really. So you're right, you have to learn to do it.
Sure. Now, to be clear, no one's going to finish it because you'd have to do every single problem in an hour and a half, which is what everybody else gets. You guys get 55, right? It's never going to happen. You're supposed to do all the ones you do know, either the ones you've already done before to prove that you still know them, and then all the ones that you're like, I do know this, I just don't have evidence yet. If you leave ones blank you've never done before, it can't bring your grade down. Now, the only difference is chapter 10, you have nothing plugged in for chapter 10, yes? Right? So you should definitely try to do some chapter 10 stuff, because otherwise you're going to have nothing when I plug that in. That would be bad.
Wait, say it again.
No.
If you don't do it on the final for the
If you don't know it, then don't do it. It's the same as any test. You can't do something you don't know. Just do the ones you know. It's that simple. Treat it like any other test. Do as many as you can. It's that simple. All right, cool. Here, let's factor this. If you had to guess, what would we need? What do you know we need? We definitely need what? Gotta have x and x to get x squared, and we gotta have m and m to get m squared, right? But isn't this negative? This gets us positive m squared, so what do we need? Hey, guess what? You did it. This is a difference of squares. See it? Difference of squares. Difference of squares always factors of conjugates. What are conjugates? Oh, formula. No, you forgot formula.
Formula.
I never have to remember because, wait, I never forget because I never have to remember.
Yes.
That's how I get around it. I never forget because I never have to remember. I can just think. That's the key. You, formula, have to remember. But check it out. It works, right? I get x squared. I get negative mx. Uh-oh, no negative m, right? X. But then I get positive mx because I have opposite signs. Goes away. Totally works, doesn't it? When in doubt, use your brain. Moving on to the intermediates, yeah?
Oh, yes.
Robeson, you heading out? Later, bud.
It's past my math class. I'm supposed to take my math at 4:30.
We need to find the solutions to this, not the product and sum. We need to find the straight up solution. So that means we got to factor. How are we going to make this easier to work with? Is 52 divisible by 3?
No.
It's really close, isn't it? Mm-hmm. So we're stuck with it. We know it's got to be 3x and x, right? If it was 51, we could have done it, right? Take out a 3 from everything, we just get x squared plus 17x plus 29. But it's a little bit off. We're going to have numbers that multiply to 149, or 147, and after one of them gets tripled, it adds to 52. This one might be unfactorable. Hold on. Yeah, dude, it's only 3 and 29. And that'll never work. Guys, change this to a 51. If we divide by 3, it'll be factorable.
And it says you may just change numbers right here.
Change number because teacher mistake. Yo.
Now you did it. Thank you.
All right.
Oppa. Oppa.
This is still bad. Gotta be double positive. 29's prime. Impossible. Skip. Sorry. Whoops. I just gave you really bad numbers. But the key is to divide, to simplify it first, and then factor, right? That's what's going to happen there. I can't believe that made that onto the test.
I definitely didn't do it.
All right. What can we do to make this nicer to work with? My apologies. What can you do to make this nicer to work with?
Sorry, repeat. I was listening.
What can we do to make this one nicer to work with?
Times by
Get rid of
two.
the decimal.
Yep, by timesing by 2, right? Is it going to be double positive, double negative, or one of each? It's got to be double negative because only 2 negatives will multiply to a positive and add to a negative. Notice that this is going to double whatever goes here before we combine it for our total amount of t's, right? So it's got to be 13 and 1, right? Where do we want the 13? Where do we want the 1?
13 big, 1.
Yep, negative 13, negative 2. Totally works. What are our 2 answers for t?
How did we get 1? I thought we had 2 there.
No.
I'm so confused. I'm so lost.
That's because you just wrote random numbers. You weren't thinking.
Oh wait, because I put the 2.
You put the t, yeah.
The T.
Mm-hmm, you did. Turning the page.
I could go on with 5 minutes.
Okay, well. The sum of the roots is negative 15. The sum is always negative b over a, right? And the product is negative 76. Well, that's always c over a. So find a quadratic that fits this. Well, let's have a be 1, right? If a is 1, that means this. B would have to be 15. Okay, cool. And what would c have to be? If a is 1, what's c going to be? Negative 76. We found a quadratic. Now it says find the roots. Okay, cool. We got to factor it. Definitely need x and x. What do we know about the signs? Can't be. 2 negatives won't multiply to a negative. It's got to be 1 each. Now, which one's got to be bigger, the plus or the minus, you think? When? These two distribute, yes? Distribute? Yes? These two distribute, no x. Must be this. Plus minus gets negative. Only way. If this is plus, double plus, so it adds to this and plus. C. Correct. Check C and then check B. Because if this is plus, could be double minus or double negative, or double plus, right? We need double plus so it adds to this. That many x's, that many x's. They have to add to this. So, example. Must be double positive, not double negative.
Yeah.
Double negative gets this, right? So you have to think. Now, if this is negative, one of each, right? Yeah? And then this goes away. But yeah. So this one, negative, one of each. This is bigger than this to make positive when we add. All right, what numbers multiply to 76 and subtract to 15? Because they will subtract because one of them is negative. Well, 1 and 76, 2 and 38, 4 and 19. And that's the one we need, right? 19 minus 4? Yeah. Negative 4x plus 19x.
The next thing I'm sure.
Christina, you see?
Okay, bye.
Bye. Next one, we know it's got to be 13r and r, right? Ooh, this is minus 15 equals 0, yeah? After moving. Christina, minus 15. Signs? Plus minus. Probably plus here. Do you know why?
No.
Big plus. Big plus. If negative, big negative. Don't want big negative. What numbers multiply to 15, and after you times 1 by 13, you get 34? Probably 5 and 3, right? Do you see? 39 minus 5. 34. 13r squared. 39r. Negative 5r. Minus 15. Yes. So r equals negative 3, and r equals what? 0. 0 minus 5, not 0.
I knew this one.
Yeah? Over here, how do we make this better? Times by 6. Okay. Definitely T and T. Christina. Minus plus. 6 and 1 or 3 and 2? Very close together, right? We're going to subtract. Probably 3 and 2? I don't know. Maybe wrong. Maybe wrong. Ooh. Probably 2 and 3. Big positive. Small negative. That's my guess. 7 and 3? 14 minus 9? No. $21 minus 6? No. Ah. You have to guess sometimes. Quadratic formula? Very slow. Really slow. Lots of mistakes, and you never catch them.
No, I don't.
We have quadratic formula too. We just learn it later when you can prove it. You prove the quadratic formula?
Yeah, I don't.
Do you know completing the square? You learn algebra too. All right, so this has got to be it, right? We get 18 t's minus 7 t's, which is 11 t's, right? So that means t's got to be negative 3, and t's got to be 7/6.
So we're just not to guess sometimes?
You're going to have to guess sometimes. I was looking in the middle because it's odd, and I was like, okay, if both of these are even, we're never going to get an odd. But like 2 and 3 and 6 and 1, you can get odds either way, so you just had to kind of guess. It is kind of lame. It's a puzzle.
And I'm never going to talk about it.
What? When will these be 0? When x is negative b over a and when x is negative d over c. Don't you agree? Yeah. Find the product of the roots. Okay, product is c over a. Negative 704 over 96. Find all solutions to this. Danger. We squared. Squaring means 2 answers, yes? Should be 2 answers? Yeah? But here's the problem. Did the original have a square? So there should only be 1 right answer. So we're going to have to check both of our answers and see which one's not real. We call that an extraneous solution. No. Distribute. 3 times 3, 9. 3 times this, x times that. Here, I'll write this out. This is what this means. 9, negative 3 for a total of negative 6x's. Positive x squared. Is this one even factorable? Plus, ooh, it's 13.
Minus 3 minus x, right? Or 3 minus...
Negative 3x, negative 6x, yes? Positive x squared. Two answers. 1, 13. Now, one of these is not real because we only got 2 answers because we squared everything. The original did not have a square, right? So now we have to test them. If I plug in 13, notice I get 3 minus 13 over here, right? What's 3 minus 13? Can you ever root something to get a negative? This one isn't real. This one is, though. 7 minus 4 is 3, root 3, right? And then, ooh, hold on. Root 3. Yes. Error. Root 3 versus equals 2. That's not true. 13 minus 4. Yeah, what's going on here? I saw, subtracting 7x's over. Oh, there we go. And then adding 4 over is 13. But then it doesn't factor. You? Yeah. Super gross. You guys didn't learn this yet. It's section 5. We couldn't go ahead and skip all the 5s. Probably should have done that. No, can't be. We didn't cover it in class. And that's all the spices, or all the intermediates. We okay? Okay. I can't believe I had 2 things on the test that were not factorable. I mean, technically part of your job is to know when it's factorable and it's not factorable. But I don't like doing that on the test. I like doing that on the quizzes more for Algebra 2. All right, that's it. You guys are exhausted now. It's 5:50. They said it couldn't be done, but we did it. All right, I will start uploading.